72 exercises, and Amber is asking about 70. Let's go over 69, which is similar to 70.
I don't like the examples that they give because they be giving examples with the same the same denominator, and I didn't understand that.
So we have to to the bottom, to do the same as in homework 11.
Right. So these, as you can see here, 69. The denominators must be the same. They're not the same, so we can't subtract right away. Let me show you how to find the LCD. So I'm going to do 69. Switch to the whiteboard. All right. So again, it's 7.2. Question. 3 over.
It's 4x. No, you're right. It's 5x. Sorry.
I'm doing 69. Okay. So the question here is to add or subtract. In this case, it's subtract these fractions. Again, as we saw last week, I believe, you always look at the denominator. It has to be the same. If it's the same, that's good. You keep it the same, and you add or subtract the tops. But now, these are different. We're going to try to see how to find the LCD. We need to make them the same. So we need to do something else. To find the LCD, we have to do an important step. But what is that step called? We have to do something.
Factor it. Factor it.
Exactly. We need to factor to find LCD. Find LCD. We're going to factor. Look at the first one, we have 3. We're going to have to factor this trinomial. Basically, factor means turn it into a multiplication. Turn it into times something. As we saw last time, we have x2 and x, so we got to start each parentheses with x, and then we need to find 2 numbers and multiply to what? 2 numbers are multiplied to
6, and 2 numbers, then you add them, it gives 5s.
Exactly. So
it'll be 2 and 3.
Positive 3, yeah.
Okay, and add up or subtract based on the signs to negative 5. Positive
Right.
negative 5. So what numbers multiply to 6 and add up to negative 5?
3 and 2.
3 and 2. But what signs would we use? Keep in mind, we want to get 6 and negative 5 from the same numbers, the same signs. We don't change them.
So it's negative 3 plus 2.
Ooh.
3 and negative 2. That way, times 2 negatives to turn to a positive. Take the same numbers, we combine them. So basically negative 3 and negative 2. So we're using negative here because they're both negative. And negative 2 minus 3 is negative 5. That's it. So this goes here. Minus 5 minus, no, the numbers, not the results. So these 2 numbers, negative 3 and 2. Negative 3 and positive. Good, so that's the first step. We factored that. Now let's do the same thing to the other one. And we want to factor first in order to find the LCD before we can add or subtract fractions. Same thing here. Trinomial. We need 2 numbers that multiply to what?
4.
Right, to positive 4 and add up to negative
4. Negative 4.
So times.
So that would be positive 2 and negative 2.
Let's see. Let's see positive 2 and
Negative 2.
negative 2. But if you times these, you're not going to get a positive. You will get a negative.
So it'll be negative 2.
Right, because negative times a negative will be positive. And also when you combine them, negative 2 minus 2, use the same number,
Negative 4.
same sign would be negative 4. So put those here, negative 2 and negative 2. Okay, so that's how you find the number. Now, we need to We need to make them the same. They're not the same. X minus 3, x plus 2, x minus 2. At least they have one thing in common. Do they have something in common?
The 2.
But this one.
Just have to add x minus 3 basically, and x minus x.
Okay, but nothing is common, right? Negative 2 times this is this, and here negative. Actually, this was a negative.
No, nothing. Well, the negative 2.
This was.
That's the only thing in common.
That's right. This.
So nothing.
Let's fix that. No, this is supposed to be a negative because we use a negative.
Right. So x and negative 2
Why
is the
did
only
you
thing in
have
common.
positive?
Right. That would be what's common, yeah.
Mm-hmm.
Okay, that's good. At least it's common. So 1 against 1.
Mm-hmm.
One has minus 3, the other one has another minus 2. So we want to make them the same. So let's go to the first one. What is it missing from here, from the second one?
What is what?
It's missing another
Yeah,
one.
because we have to add one more because it was in double, like x minus 2. And
That's right. So we're going to add one more here because this one has 2 of them. This must have 2 of them too. So we're going to times here. Also the top, you're going to multiply by the same thing, x minus 2.
Well, why?
Because we want to make them the same. So we're going to complete both of them. One, they're going to complete each other, so they could end up exactly the same. All right, so the first one, we had to add another x minus 2 because this one has 2x minus 2. Now, to the second one, what is it missing from here to look like this one?
X minus 3.
That's right, so we just have to multiply because this x minus 3 has to be in both. That's how we make the denominator the same, the common denominator.
Are we going to do x minus 3 on the top too?
That's right. So if we times this by x minus 3, also need that over here. That's it. As you can see, we both have the same thing. Now we have 2 fractions with the same denominator. We can go ahead and add them or subtract them. So this now, as complex as it may look, it's just something simple like, for example, this minus 1 over 5. Just an example. So when you subtract 2 fractions, you look at the denominator. If it's the same, that's good. And what do we do with the denominator?
Keep it.
Keep it the same. In this case, the denominator happens to be this whole thing. But it's no big deal. It's the same concept. We're going to keep it the same. And the top, we're going to subtract 2 minus 1. 2 minus 1 and simplify. This is just an example, okay? Not the problem. It's just an example. But now let's do the same thing with our actual problem. So the denominator will be the same. So this one will be here. Let's just call it, just write it down actually. X minus 3, x minus 2, x minus 2. Okay, just like we did here. We subtract the top. Let's do the same thing. We're going to take the first top, 3x minus 2, minus this. I'm just going to write them down and later simplify.
This will cancel out, that will cancel out.
So
this will cancel out, that will cancel out.
Before we cancel, we can't just cancel anything right now. We have to simplify the top. We have to first simplify this, combine like terms, multiply. So we're going to multiply first. So minus 6 and negative 2x plus 6 over the LCD. LCD meaning this. I just want to write the whole thing again.
Or we can just do like x minus 2 in the second, what's it called? Like that.
All right, so now what do we do here at the top? We combine like terms with 3x minus 2x. What happens to the negative 6 and positive 6? They cancel out, right? We have the LCD left. LCD meaning this. And that's basically it. Okay, main step again.
Are you serious?
I did not understand nothing. Sorry.
What part? What's
you lost me. Where is the part where you put the red pen? You lost me right there.
All right.
Because you said you said x in the bottom, the we have x minus 2 and then x minus 2, and then the line that it means cross it out to x minus 2 that we have extra, but then you add another x minus 2.
That's right. So let me.
I don't get it. I just.
Okay. So again, so we had these two fractions. First, we factored them. Okay. Let me write that here. So we factored this into x minus 2, x minus 3, x minus 2. This one we factored into x minus 2, x minus 2. So we want to make them the same. We want to make these the same. They're not the same. So we can't add them unless we have someone like this. Once we have the same denominator like this, we can't subtract. So in order to do that, so we need to make them the same. So let's start with the first one. What is this one missing from here? We're trying to make them look exactly the same. What is this one missing? Minus 3x minus 2. What is it missing? What is it missing from here?
The 3x.
No, this one. It has x
The
minus
2x.
it needs two of them, right? This one has this one, x minus 1, x minus 2. This one must have both. So what's missing here? One of these. We're going to say x minus 2. Why? Because this one has two of them. This must also have two of them. If you times the bottom here, you got to times the top by the same thing. Now, going back to the second one, does it look like this?
No.
No. What is missing here? To be like this?
X minus 3.
That's right. So we're just going to multiply this by x minus 3. Don't forget, if you multiply the bottom, the top also by the same thing. That's it. So once we made them the same, basically we have something like this. Two fractions with the same denominator. You keep that denominator here the same. You just have to subtract the tops. 2 minus 1. This is just an example. But our actual fraction is this one. So that's the LCD. So we keep this the same. So we don't write it twice. Just like 5, we write it once. That's what we did here. So that's the LCD. And we just subtract the tops. This minus this. That's what we wrote here. Then we distribute, combine like terms to simplify. 3x minus 2x is x. Minus 6 plus 6 cancel out. So we end up with x left at the top over the LCD, meaning over this whole thing. The LCD is x minus 2, x minus 2, x minus 3.
Or we can just leave it x.
Huh?
Or can we just leave it x?
Have
to specify saying LCD, sorry.
Yeah, so this, basically that's what's left at the top. And yeah, you can just write LCD instead of write the whole thing.
No, I said, can we just leave it and say it just equals to x? That's it?
No, it has to be over this. It has to be like this. It's a fraction. Just like here, for example, 5, it's 2 minus 1 over 5. You have to have the denominator. So this is 1 over 5. That's the final answer. Not just x, it's 1 over 5. Here, x over LCD, meaning this. Okay.
And why did you put just LCD instead of putting the x minus 3?
Yeah, I just didn't want to write the whole thing again because you may have to write it a few times. So just to make things neat and easy, we know what it stands for. So LCD here means this. So as you go, you don't have to write it 3 or 4 times because there might be more steps. So we could just say LCD. We're referring to this when we say LCD. Okay?
Okay.
Professor?
All right. Yes, Mariama?
Yes.
Okay, go ahead.
Instead of writing the x minus 2 times, can we write x minus 2 square?
Yes, definitely. These two here, you just say as x minus 2
square.
Because there's 2 of them, you can, but you don't have to because we want to keep it like this, just in case you want to cancel something from the top against from the bottom. But that's fine. If you do that, it's still okay. Okay?
Okay.
All right. Let's take another question. So that was Amber's question. Anybody else? Another question?
Yeah, I've had a question about the homework 10. And I think it was like
What
I
unit?
put two questions. Sorry?
What unit?
6.2.
6.2. And
And that was 28 and 30. I just don't remember.
28 and 10. Okay, let's go.
Let me see where it is.
Okay, it's opening up.
Say it again.
Okay, one second. I'm loading the page. So 28 and 30, right?
So 28 and 30, the exercise, unit 6.2.
Okay. I believe.
I'm just trying to open it as well for me so I can see that because I put it on my homework, but I don't remember what was it.
Okay, I believe we covered this last time, didn't we?
Yep, we already did that.
No, we actually did like a homework 9,
Mhm.
but when I started doing this,
You're
it
talking about
didn't
this question,
really.
right? 28 and 30.
Yeah.
I remember we did 29.
No, last time we did 11 and 12 already.
Yeah. So below last time.
Oh no, I mean I did the rest of the homework. I didn't have any problems with other homeworks, but like what I was stuck during all this time, it was functions and homework 10, these few questions. I mean, I can skip them because I did the rest of the homework, but like since we asking, I will probably ask about this.
Okay, so do you need help now with the 28 and 30?
Just you can just explain very fast because when I was trying to like
Okay, so
what it was
29
confusing.
last time was similar to 30, right? 29. So basically, we need two numbers that multiply to -15, as you can see here, and add up to
Right, and then we can do the plus, like the one which is in sum, yeah.
we couldn't find the numbers, if you remember last time, you can't find two numbers that multiply to -15 and the same numbers add up to -3. And we said this was prime. It doesn't factor, basically stay the same. I believe it was Mariama who asked this question last time, right, Mariama? Mariama? Barry?
Got it. So you're saying
Yes.
Okay.
you're saying that if you can't find it, then you just say that you can find it, right?
Yeah, just say prime or can't factor because it's prime.
Okay.
Okay, so it's similar.
Yeah, because the rest is pretty easy. It's just that I didn't understand because you know when you go to the like it shows you examples in the book, it's so confusing. It starts showing you like all the numbers between like A, B, and C basically.
Right.
And then it's just like it gets me so confused. So okay.
For this
we can
one,
skip it now.
examples 1, 2. Okay.
Yeah.
All right.
Thank you.
No problem. All right. Next question.
Let me try to see my question. I do have one.
Hosseini, are you with us? You good?
Yeah, I'm just looking at it.
All right. Kiara?
I've done all my homework. I hope you got them right.
Let me see. I don't remember getting
You're
it.
rolling.
Morning.
I'm missing.
Mine, but got not response.
Hosseini, let me check. I'm not sure, but I don't remember seeing anything from you only recently. No, Hosseini, I didn't get anything from you recently.
How about me?
I sent them yesterday.
No, check your inbox, your sent box.
Okay.
The last email I got from you is when you told me about the email issues, and I told you and I responded. That's it.
Okay.
So every time you guys can check the sent items in your sent box and see what you sent me. If it's there, if it says sent, then I got it. If it's not there, it means I didn't get it.
Okay.
So you didn't get anything from you. Who else asked?
Professor, usually when I sent you an email, I got a response. But yesterday I sent you my homework, but you did.
I saw something yesterday from you, yeah.
Okay.
So, Mariama. You said 11 and 12, right?
Yes.
Okay, I got it. Anybody else?
I have a question
Mhm.
on homework 12, I think. Yes.
Which homework?
Homework 12.
12. What unit would that be?
I don't remember the unit, but I know it's
I'll tell you right now, the 12, right?
Let me.
It's 7.2.
Okay, okay, 7.2. All right. What's the what's the question number?
exercise 42. I already did it, but it seemed a little bit complicated.
Okay, let me check. I'm opening the book right now.
After this session, are we gonna be doing for the homework 13 and 14? Like examples from each thing,
Yeah,
so
we can discuss some of that. Yeah.
like we did last time,
That would
right?
be great, yeah.
I'll show you the next lesson. So let's first finish with these questions. So exercise or unit 7.2. What question again?
Exercise 42.
42. 42. All right. What did you get from it?
My final answer was 2/9 AB.
Okay. We're gonna get disconnected in about 10 minutes. Please rejoin the meeting right away using the same link. Okay, so 40, you said 42, right?
Yes.
Let's do 41. You guys see 41 here? 5 over 12x is second y minus 11. So the question again is add or subtract. In this case, it's subtract. So same way, we need to make the denominator the same. We need to find an LCD. Okay, let me open whiteboard for this. All right, so this is 7.2, question number 41. So it says subtract. We have 12x squared minus y, 6xy. All right, so again, we can't subtract. These are different. We're going to try to complete them. We're going to complete each other until we make them exactly the same, then add. Let's start with the numbers. We have 12. Here we have 6. How do we make these the same? Everyone, I want your attention so we don't have to repeat it again. So we have
Factor it.
The 6
We
has
have
to
to-
multiply, right?
so this is
No,
already
we have to, so first of all, we have to do like a 2, and then to open up, and it's gonna be 6,
Don't we have to
Six.
multiply 6 by to have the same denominator?
that's
Like
right. That's right.
6 times 2.
So this one
6
doesn't need
times
to be
2x.
You have to drag the numbers.
Has a collection of 66
Okay.
baseball cards.
So it can be 2x, right? Times 2x.
That's right. So let me explain it. So
it's
basically,
gonna be 2x.
yeah, just
and
give
that's
me 1 minute. Let me go over it. So basically, we have 12. We have 6. They're not the same. We can factor this. It's already factored. It's already multiplications. Just one term. It's not 2 terms. It's already multiplication. So no need to factor unless you have trinomial x plus this plus that. So first start with the numbers. You want to make this the same. So 12 here, 6. To make it the same, we're going to times it by 2. Also, always do the same on the top. Good. So the numbers are good. 12 and 12. Now we have x2, but this one is x1.
There's another x.
So we need x. That's right. So this one has x2. This one has x1. This needs to also become x2. So to do that, we're going to times it by x1, right? And also do the same at the top, times x. Finally, do we need to change the y?
No.
No.
The
Just
same.
keep it.
The y is the same power, 1 and 1. No need to do anything. Okay, so only had to multiply here by 2x and here by 2x. And you're going to see it's going to be exactly the same. So 5. So 12. X2 and 1 minus, what is 2x times 11?
22x.
That's right, 22x. Same thing here, so 2 times x will be 12.
Wait, but then you can't subtract it because the 22x and the 5 is not the same, right?
And it doesn't have to be the same. Only the denominator needs to be the same.
Oh.
Okay.
It's gonna
So
be
here, so 2
12x
times 6
squared,
is 12. X
12x
times x
squared.
is x times x.
X squared.
X squared, that's right.
X squared. And then y.
And y, just y over y1. So you see, they're exactly the same. That's good. Now we can go ahead and subtract them. Again, the denominator will stay the same. Okay, x1. And the tops, we're going to subtract them. 5 minus 22x. And that's it. We can't simplify here. We can't add or subtract. They're not the same. But if we can, try to factor or combine like terms. See if we can cancel something from here against the bottom. But in this case, that's it. We can't do anything else. Okay, there's no common factor between 5 and 22. No like terms. Okay, so that's basically how you find the LCD. You just play around with the, look at the numbers and the x's, y's, make them exactly the same. Multiply what's the side that needs to be multiplied. Okay, so that's not that bad.
Yes, that one is easy. The only thing that is complicated with the 42, when you find the common LCD,
42 is the same way. So 42, the exact same way. You got to make the numbers the same, the A is the same, and the B is the same. Okay. For example, 18, and we have 9. So we got to make that 9, we're going to make it 18. Okay.
Yes, yes, I did that.
And we have A3 and A1. So A1, we got to times it by what to make it A3? Right? So just need to make multiply. So the powers are exactly the same, the variables the same. Okay, so 42 is very similar to this one here, 41. Okay?
Okay.
All right. Everyone, Kiara, Dilnoza, are you guys all right? On board?
Yes. Yes.
Yes.
Thank you.
Okay, please let me know if you have any questions at any time.
Okay. Thank you, Professor.
All right.